Welcome to Culture, Worldview, and Origins. We're Tim and Holly Nyquist. We're in the 13th chapter, Kuhn Critical Thinking, session number 5. Session number 5 is chapter 5, and the title is The Priority of Paradigms. So this chapter is going to focus in on paradigms. We ended the last chapter talking about paradigms and how one must practice normal science within certain boundaries, certain rules, certain expectations enforced by that paradigm. The priority of paradigms. These are the community's paradigms, revealed in its textbooks, lectures, and laboratory exercises. By studying them and by practicing with them, the members of the corresponding community learn their trade. Okay, so again, scientists that are learning their trade often apply the rules, apply and use the paradigms, but it's not often spelt out explicitly because that is philosophy. And philosophy is not really a part of science, even though science uses a lot of philosophy in it, but it's only a determined philosophy, so it's not open to general philosophy. But so they study the paradigms, the community paradigm, as revealed, but the paradigms revealed in the textbooks, lectures, and laboratory. By studying them and by practicing with them, the members of the corresponding community learn their trade. Despite occasional ambiguities, the paradigms of a mature scientific community can be determined with relative ease. Okay, the paradigms can be determined, but all of its component parts are not as obvious. And those need to be intentionally studied, intentionally observed to understand what are the component parts and what are each one. But as a paradigm in total, yes, you can look at the mature scientific community can be determined with relative ease. The determination of shared paradigms is not, however, the determination of shared rules. Okay, you could, in other words, they're saying you can share a paradigm within a community, but it might not be shared rules or not all the rules. And that is the case of the different models of evolutionary science that are proposed, evolutionary theory, because we have the Darwinian theory that has their major paradigm. It's all under the major paradigm of evolution, but you have slow, gradual changes versus punctuated equilibrium of Stephen Jay Gould, which is radical revolutionary changes. And so you have them under the same paradigm, but they have some different rules to them, different ideas of interpreting. As a result, the search for a body of rules competent to constitute a given normal research tradition becomes a source of continual and deep frustration. They can, that is, agree in their identification of a paradigm without agreeing on or even attempting to produce a full interpretation or rationalization of it. So that's what's been mentioned, is that the scientists or the people that are being trained as scientists, they are trained by textbooks, lectures, laboratory experiments, and so they're trained in the paradigm of how things are to be done, but they may not be trained in the specifics of what are the rules, what is the underlying, they can't or maybe be able to produce a full interpretation or rationalization of what they are doing. In the absence of a competent body of rules, what restricts the scientist to a particular normal scientific tradition? Well, again, what we have is that the paradigm, the paradigm, which is the priority of paradigms, the paradigm is what gives the boundaries without us maybe understanding what are the particular rules that implicates. If I follow this, then what are the implications? And that's what a lot of us are guilty of a lot of times, is that we follow a model of science without understanding the implicit rules, and those rules might actually violate what we personally believe. And so we have to be careful, and we should examine the paradigm and examine the rules that are within that paradigm to see if we actually agree with those rules, and not just practice a paradigm without understanding what the implications are and what rules it goes by. Paradigms may be prior to, more binding, and more complete than any set of rules for research that could be unequivocally abstracted from them. Okay, the priority of paradigms. The paradigm is the king, and it may not be explicit as to what are the contents of that paradigm, what are the beliefs and assumptions of that paradigm, what is the metaphysical implications of that paradigm, but we accept the paradigm as complete without maybe understanding all of the rules, but we stay within the boundaries of that paradigm because we understand maybe intuitively where we can go and where we can't go without being explicit about those rules. So far, this point has been entirely theoretical. Paradigms could determine normal science without the intervention of discoverable rules. Okay, so those are kind of the key terms there, is that normal science, paradigms could determine normal science without the intervention or discovering what the rules are. So we may not be able to name the rules but we know how it's to be practiced. So as a paradigm completely, and as a worldview, we know how and where the boundaries are, but we may not be able to verbalize exactly what the rules are. And I think that, again, that is maybe a failure a little bit on our part, in that we need and should teach the rules along with the paradigm, so that we know whether or not we're on board with that paradigm. And but I guess that there is reasons for not teaching the rules explicitly, because then that might create separation and dissension within the paradigm. Again, so what is a paradigm? We're talking about this chapter is on the priority of paradigms, but again, we didn't have one completely defined, so we're towards the end of the chapter on chapter 5 on paradigms. So what is a paradigm? A paradigm is a shared worldview. A shared worldview. Now, if you're just talking about it's viewing the world, a shared worldview, many of us have a shared worldview without even knowing what that means, or without defining what that means. But if you go through the three different sections of the German worldview of the Weltbild, then that is the world picture, how you picture the world, which includes all your experiences, your upbringing, your theories, your everything that influences the making of your picture. Then the worldview, the Weltanschauung, is the action of viewing the world through that picture. And so it's like glasses that you're looking at it. And so it's kind of like a paradigm is a shared worldview. Without defining paradigm in detail, without defining worldview in detail, what Kuhn is saying is that a paradigm is a way of seeing things. It's a way of viewing things. So one, it is subjective. It's personal. And that would go in line with Stephen Jay Gould's concept of, no, we don't all see the same thing because of theory, habit, prejudice, and culture. So a paradigm is a worldview that points all its members in the right direction. And while there are rules that govern how the community proceeds, these rules are implicit. One is at liberty to suppose that somewhere along the way, the scientist has intuitively abstracted rules of the game for himself. But there is little reason to believe it. Okay, so he's saying, this is Kuhn, one is at liberty to suppose somewhere along the way the scientist has intuitively abstracted the rules of the game from the textbook, from the lectures, from the lab assignments. From those, because the rules are not taught explicitly, Kuhn says they may discover the rules then intuitively, abstract them for the rules of the game for himself, but there's little reason to believe it. So Kuhn says, yes, they may be able to do it, but I don't believe they do. I don't think they understand the rules. I don't think they even think about the rules. They just practice science according to the paradigm that's given them. Normal science can proceed without rules only so long as the relevant scientific community accepts without question the particular problem and solutions already achieved. Okay, so you can go without rules as long as you stay within the group, as long as you not understanding the rules of the boundary, but if you're within the group, you just follow the group and you don't need rules. And that way you just intuitively or whatever, you look for problems and you look for solutions and you offer solutions according to the paradigm. But the paradigm is not explicit in what it stands for. And he believes it stands for a worldview, but the worldview has rules, and those rules are not usually explicit within the scientific context. If normal science is so rigid, and if scientific communities are so close-knit as the preceding discussion has implied, how can a change of paradigm ever affect only a small subgroup? Well, that is a paradigm, a general big paradigm, which we'll get into in chapter 13, an overarching paradigm that controls all groups is different from a paradigm that controls a subgroup of a specialty, because different fields or disciplines of science practice things in a different way. And so there might be different paradigms in different subgroups that don't affect other groups. So there could be changes within a subgroup that does not affect science in general. Goes on. In short, though quantum mechanics or Newtonian dynamics or electromagnetic theory is a paradigm for many scientific groups, it is not the same paradigm for them all. Okay, so this is what he's going into, is that subgroups can have a small paradigm change, but it wouldn't affect the overarching paradigm. It would affect a minor paradigm or minor theory within that subgroup. So not affecting the overall. An investigator who hoped to learn something about what scientists took the atomic theory to be asked a distinguished physicist and an eminent chemist whether a single atom of helium was or was not a molecule. Both answered without hesitation, but their answers were not the same. Okay, so what he's talking about here is he launched a question: is helium a single atom or not? And he asked one to a physicist and the other to a chemist, and they both came up with yes and no, different answers without hesitation, because from their field, their specific paradigm knew that to be an atom, it had to be this. To be an atom, it had to be composed of this. To be an atom, it had to act like this. And it in one field, it qualified as an atom. In the other field, it did not. And so it's kind of like he's just showing that, okay, within science, there can be differences of opinion between fields or disciplines of study because they all operate within their own paradigm. And the paradigm might be a little different from chemistry as it would be to maybe the physics, but the overarching paradigm is still the same. So there could be minor paradigm changes or functions of different kinds of paradigms in the different specialties within science. This is on paradigms. What does a paradigm do? What can we say a paradigm is? A paradigm, according to Kuhn, is a worldview. But then a worldview is not discussed in detail. But what he does say is that within those, there are rules. But the rules in science are implicit. They are not explicit to the point that they're taught, that if you accept this paradigm, these are the rules that accompany it. Through the textbooks, through lectures, and through lab experiments, what is taught is the paradigm and the worldview. Now, if someone is to get to the rules, that is more an individual effort. The rules are there. It would be an individual effort to get to them. So that's this chapter. This section is on paradigms and how it affects science and how science needs paradigms, but at the same time, the paradigm is not explicit. We're Tim and Holly. We're on chapter 13, Kuhn's Critical Thinking, session number 5. Thank you again for joining me, and see you in the next one.